Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, while our topic is series circuit. So, aim of today's lesson is for you to understand what is a circuit connection. Okay, instructional materials diagram of electric circuit. While today's objective is for you to know about current, potential difference, resistance of each component in a circuit, and how to calculate series circuit. But before going to series circuits, I need to remind you what a circuit is. A circuit can be defined as the pathway in which current flows. So this current can flow in a circuit in two ways. That's why we call it series circuit or a parallel circuit. But our topic for today is series circuit. So how do current flow in a series circuit? In this circuit, the bulb, we call it cell, right? And the switch are connected in series with each other. So when the components are connected in series with each other, so what do we call series? Series is when there is connection between head to tail of other components. So if a component is connected from head to tail to the other component, then we call it series circuit, series connection. So the same number of electron passes through when it is a series connection. Okay, so the same amount of current, the same amount of charge pass through when it is in series connection. So let me show you how a series connection is. Remember that this is a cell, but when we have two of these, then we'll call it what? Battery, right? So here we have our switch. So we have our switch here, and we have our ammeter here that we use to calculate the current flowing in the circuit. We have our voltmeter here to calculate the voltage in the circuit. And this is another component. And this is a lamp here. Okay. So now this component, which is the lamp here and the voltmeter here, they are connected in series. Why are they connected in series? Because it's a connection from head to tail. Because this is from the head. The current coming from this ammeter is the same current that flows through this voltmeter back to the lamp itself. So this is what we call head to tail connection. Okay, because as the current goes in, there is no another, should I say there's no another wire or another nodes where the current will pass through. So the current coming from the voltmeter is going directly through to the lamp. That's why we call it a series circuit. So in a series circuit, the same current passes through each component. So any electrical part that is in the circuit, we call it component. Even the ammeter, the voltmeter, the thermistor, the lamp, all of them are a component to the fact that they are in the circuit. Okay. So here we have two lamps. So these lamps here are connected in series because it's from head to tail connection. So the current coming here from the ammeter will pass through this first lamp and it will go directly through the second lamp. So that's series circuit. So in a series circuit, the total potential difference of the power supply is shared. Now, to the fact that we have the same current passing through them, their volts will be shared. Why? Because they are connected in a series circuit. They are connected from head to tail. So the total potential difference, which is the PD, we all know that as our voltage. Okay, so we call it the total voltage in a circuit, that is in a series circuit, can be defined as the summation of all the voltage in that circuit. That will give us the total voltage. Okay, so that's why we have our VT equals to V1 plus V2. So in a series circuit, voltage is shared, but current is not shared. Current is constant, but voltage is shared. So let's go to resistance rules for components in series circuit. So what is resistance rules there? Remember, in Ohm's law, we said that the current flowing in a circuit is directly proportional to the potential difference across it. So if the current flowing in a circuit is directly proportional to the potential difference, which is V, is directly proportional to I, but the proportionality constant there is what we call resistance, which is R. And resistance means it resists the flow. That means it reduces the flow of current in a circuit. So what happened to the resistance in a series circuit? What reduced the flow of current in a series circuit? To calculate the total resistance in a circuit, thus the total resistance of two or more components in series is equal to the sum of the resistor in each of the components. That means to solve for the R total in a series circuit too, we need to calculate all the resistor in that circuit. That's R1 plus R2 to Rn. It depends on how many resistors do we have in the circuit. So I want you to take note now that I is constant. That's why I will use C to name it as constant. But we need to find the value of R, which is the total resistance. And we also need to find the value of V, which is the total voltage. But only I that is constant in the series circuit. So let's say 3 ohms. Let's say we have this resistance as 3 ohms. And here we have 12 volts. And here we have 3 ampere, 3 amps. And here we have 2 ohms. Now here we have 2 ohms. Here we have 3 ohms. Okay. So now what I'm saying now is 12 volts. What I'm saying now is 12 volts passing through this will be shared because of their resistors, 2 ohms and 3 ohms. But the 3 amps that is passing through this circuit will be constant in both 2 ohms and 3 ohms. So that's what we call resistance, the total resistance in the circuit. So to calculate total resistance in the circuit, we just need to add all the resistance in that circuit, that we have the total resistance in a circuit, just as this. Okay? So in a component has, in series circuit, a component has its own voltage because we just need to, because the voltage is being shared, so we need to calculate the voltage in a certain component in a circuit. Okay? So if you have 1.5 cell, that's the 1.5 voltage, is the one flowing through into this circuit. To the fact that this circuit is series circuit, that means 1.5 voltage is not the voltage that will be flowing into the 2 components. Why? Because they need to be shared. But if we have 3 amps flowing into this circuit, then 3 amps is flowing through into the 2 components. So that is how series circuit works. So that will be the end of today's class, series circuit. We'll meet in our next class, parallel circuit. Thank you for watching, and please don't forget to click on the subscribe button. Bye.